First, we've got some technical issues, but no problem. We are solving that right now. First question to you, do we have any English speakers here? Yes, cool, okay. Right now you cannot see my presentation, but that's not a problem. Because first few slides are only about talking. I will, presentation is on the pen drive. Okay, so who am I? I'm Sebastian Malaca. As you can see, I'm a speaker, trainer. I'm working at UBS as a software developer. And also, if I got this opportunity, I want to invite you because on the 20th of October, we will have open days. Mainly there will be presentation of my project and other one. So if you want to talk or move, you are looking for opportunities, just go to our stand and ask us about details. Okay, I'm fanatic of clean code, and my fanatism is not about clean code for the sake of clean code. I think that clean code is a tool. It's extremely wide tool, but we are using this to meet business requirements. We want to earn money, save money, help business to chase money, to look for opportunities, and so on. That's why we need clean code. It helps us to maintain the code. And that's required to change of the way how we are thinking. Clean code is not only about design patterns, way of creating of your architecture, refactoring, testing, blah, 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 blah. All of those principles you can heard about. Clean code is about the way how you think of your application. What is the most important thing in your application? It's a business. Without the business, your code can be the cleanest code. But without the business behind it, it's useless. No one will pay for that. It has to meet requirements. And that's why when I first read about event processing, I really like this idea. I really like this concept. Because event-driven approach, the way of thinking is not starting in IT industry. It starts in the business. The first concept when you are starting to read about events is business event. They find out that there are triggers for each action, for change, for removing something, for delaying, and so on. So that's why I read more about these events processing, events-driven architecture, and that's why I also want to share that with you. Okay, this is mine. Okay, cool. Yeah, so that's me. Agenda. I will tell you something about event processing, event-driven architecture, but theory is good, but we cannot focus only on theory, so I prepare some how we can use the concept of event processing. So this is our agenda. Let's take a look at the domain used in our example. Did you heard about tools for support of continuous integration? I don't know, Jenkins, Travis, TeamCity, what else? Do you heard about it? Okay, cool. So it's about triggering builds. One build is run. If it's green, then we are moving forward. And eventually, if the last final one is green, we are merge it to our code base, master branch, the most important branch, to other branches. Depends how we configure that. There we may have some notification. I don't know if build on my pull request failed, I will receive a notification as an author. If build of on our master branch will fail, everyone will receive a notification. We can generate some reports and so on and so on and so on. Okay, so this is our domain. What is event processing? Event processing is about consuming, publishing, and mainly about operate over the event. So we need to recognize the event. PROIDEA organize a JDD. It happened, yeah? So they open call for papers. They send an invitation to the speakers. Invitation was sent. So this is our event. Something happened. Now we are doing something about it. When I saw that call for papers are open, I start to operate. Okay, Sebastian, let's think about the presentation. Okay, I've got the topic, I've got the description. I can send it to them, and I'm sending this call for papers, and my proposition was sent. This is yet another event. This is about event processing in the most briefly way. Really, next thing in event processing is event-driven architecture. But let's start with the steps. We've got an event on the very beginning. Event is anything that happened, everything. It doesn't matter whether I observe that, I don't know, rain is raining or stopped. I don't know. I don't see that. I don't know about that because I have no opportunity to look through the window. But it's happening. Sebastian is speaking, or Sebastian started a talk. You can see that. And you can react on that. You can do something about that. If you will notice that Sebastian talk is boring, you can leave the room. Or maybe Sebastian talk is nice. You can share a tweet. You can react on that. Different event triggers an action. But each event can not trigger any action. I feel, for example, you are here. Sebastian talk is nice. Okay, it's interesting. You don't have to do anything with this event. You don't want to leave a room. You are already here. Yeah. So this is about events. Another thing, if you are talking about IT industry, we've got separation over the system events and the business events. Business events is everything that. Okay, let's take a look at business scenario, system tests. Everything that is with this when part, then part, this can be translated to events, business events. Business events are extremely related with the business. Those are the events that you can build your conversation with a business analyst, customer, and so on. System events are, of course, related with an implementation. So it doesn't matter whether I will write an application in Java, in .NET, in whatever else, JavaScript, it doesn't matter. Business events will stay the same. System events will change. Business events is not dependent on the implementation, system events are. Okay, next step, event objects. Of course, Java is object-oriented programming, so we can translate it into our objects. Event object is bigger concept. Event object is everything that gives you information about event that happened. So it can be a report, it can be a spoken message, it can be everything that brings an information about something that happened. Usually we implement it as objects in Java. Event-driven, it's this behavior that is triggered after some event happened. So presentation started. I'm talking, you're not. This is event-driven. And driven architecture, it's implementation of event-driven behavior. This is creating whole architectures that using event processing across the whole application. Okay, we got a couple of principles of event-driven architecture. First, we are reporting current events. So we are notifying about things that happened. This is important, things that happened. Those are this is about everything that happened. Next thing is we are pushing notification. The producer, the piece of code that do the job and is able to recognize that something happened is pushing notification, is throwing a notification farther, moving information farther, and then eventually there may be a consumer that will be interested in this notification, in this event. Response immediately. each event have to be consumed. No, each event that we are interested in have to be consumed right now. Of course, we can sometimes be interested in delaying some further operation. Then we will talk about time request. I will cover that later. We can wait for more events because we want to gather some statistics, and so on. But each event that we are interested in have to be consumed in the very beginning. Next thing is communication one way. So it's like fire forget. Producer is publishing the event, and it doesn't wait for the replay from the consumer. To be honest, producer doesn't even know if there is any consumer interested in this specific event. It's free of commands, so I cannot tell you that after something will happen, you have to do something. I don't know. Exception is thrown. Yeah, this is an event, but the event is not an exception is thrown and you have to log it. No, logging it is an operation over the event. This operation will be triggered after the event consumption. Okay. Events. Let's start with from the very beginning. So event is everything what happened. We've got 3 types of the events. And this is state change view, happening view, and the detectable condition view. I will start with the example and easier. So state change example is about everything that changed. We've got our branch, master branch, and there are plenty of unit test builds. Yeah, and after some build, pipe is broken. So of the whole builds pipe, state of it is changed. Build is broken. Eventually, we've got another one. Builds are fixed whenever we observe the green build. Yeah. So these events bring information about changing of the state. But this is not all. We've got also happening events. They are informing about everything that happens. So build is completed. We don't care whether it's a green build or red build. We will recognize that in this place, but this build is completed. So everything that happened is a happen, and we are publishing then event. This is happening view example. Another thing is detectable condition example. So we are publishing events under some circumstances. So if I've got 5 green builds and I'm receiving yet another green build, I'm doing nothing. If I will receive yet another green build, I will do nothing. But once I will receive build failed, once the next build will fail, and I will consume this event, then I will publish the event. It depends on the condition. Detectable condition example, detectable condition view of the event, and happening view events are standing in the opposition to each other. Here, we are informing about everything. Here, we are informing about everything that was noticed, that is interesting for us. There are some preconditions for publishing an event. Okay, so let's move forward. Behavior, events, so there have to be interactions. There are 3 types of interactions, and probably you already know all of them. We've got time-driven interactions. So in our continuous integration tool, we can generate a health report of the production. And we can trigger this daily. Every morning at 8 o'clock, we will trigger this operation and it will happen. This is time-driven interactions. We can have request-driven interaction. So we can manually trigger a build. There is an interaction, is a user that is triggering it, and it always requires a response. So yes, this build pipe was triggered. or we are waiting just for the completion of it. But in request-driven interaction, we always expect a response, that our request was either approved, accepted, consumed, or not. There was a failure over it. And yet another one, and this is the most interesting one from the perspective of the talk, is event-driven interaction. We are just publishing the event. We are informing that something happened. And the piece of the code that is publishing this information doesn't care what will happen in the event. Its only responsibility is to send an information to every subscriber or consumer in your application that something happened. What you will do about that, how you react on that, if anyhow, it depends on you, and producer doesn't know that. Another concept in event processing are complex events. Complex events are about, it's something bigger than an event. We've got few types of the events. First event, those are the ones that are consuming the event and are enriching the event and put more information into it. For example, I'm interested with build is completed. This is our simple event. I don't know, we've got information of the host where this build was run. Okay, and I'm building my complex event. So it's reading the reports over the build, whether the build failed, crashed, succeed, and create yet another event with more information. But there is no computation, there is no decision making over the first event that triggering this enrichment. No, we are just putting more information there. Also, we've got yet another type. Those are the events that aggregating more information. I don't know. Oh, I've got an example here. We want to have a daily performance summary. We want to build this report. So through the whole day, our event process is consuming the events once performance build is completed. It's consuming them, storing them, and based on the information there, it creates some summary of the performance. Degraded, it's still okay. Something that we should worry about. All informations are there. Here we've got only information on which host the build was run. Here we are looking for more information, and we are summary those information. We take average. We are do some additional calculation. Then we are publishing an event. But there are more types of the complex events, and the two interesting ones are uncertain events and absent events. So uncertain events are about things that requires further analysis. For example, there were a couple of performance builds run. I don't know. We've got 24 because we are running them once per hour, and 5 of them took too much time. So here we can make a decision. Potentially, this performance is degraded. Performance of our application degraded. But there can be various reasons of that. Maybe our hosts were occupied by different builds. Maybe something was down. It requires analysis. So these uncertain events give you information about some possibilities. It gives you information, but you need to do something with this information. It is a trigger for your analysis, for yet another processing of the event. Another thing is absent event example. We are building a performance report over each performance build. So it waits for each event. Once per hour, it had to receive one. and it didn't receive it. Lack of the event trigger an action as well. In that case, our performance build is not finished. We want to do something about that because we want to know whether this is something done on purpose. Maybe we are upgrading our app, maybe environment, maybe we are switching to yet another tool. Something happened, and we want to know about that. And something that happened, this event is based on the thing we didn't receive any information. From the real life, if I got a daughter. If she will go for the party, and I told her, call to me at 10 o'clock, and she won't call me, the lack of the event will trigger an action, not the event itself. If she will call me, everything is fine. There will be no action over it. But if she won't, then something will happen. Okay. So this is about concepts. And let's talk about more juicy part, how to create, how to design your application. Event design. First thing first. Events have to be immutable. Something happened. It cannot change. If something happened, it's already in the past. We cannot modify that. We can enrich that with an information and create complex event, but this already happened. If build failed, we cannot change it into build succeed. No, because this build failed. So those events have to be immutable. Events transfer the information, as many information of the event as possible. All the information that producer can put into the event should be in this object. Also, the events are not your domain objects. Those are only at the report that something happened. After consumption of it, your architecture should be created in the way, designed in the way that you will be able to just throw them away if you don't need them for further analysis. If there is no other consumer that is waiting for the event. Then, after the reaction over the event, you can get rid of it. So something about name. It has to be past tense. It is something that happened. So we've got our version control system. We are committing we are creating a pull request. So pull request was created. Not build is starting. And it's easy to understand. However, it's extremely hard to write the code in this way. And I know that because we had this problem in our application. What's the main difference in here? This suggests what I should do with it. Here, the producer doesn't give me information what just happened, gives me information what I want to do with it. What the problems are further. First, I'm losing the information itself. Don't know that pull request was created. This is the first thing. Yet, think, what if I would like to send a notification whenever pull request is created? This event should trigger sending a notification that pull request was created. Pretty tricky. So something that happened. Another thing, not what happened, but past tense, and what happened I just covered. So yet another thing. You can even use the past tense, build started. This is also a problem that we had in our application, that we published the event that just trigger the appropriate action. It's not the way how we should do that. Why? Because there can be yet another consumer for that event. And I want to consume this. I want to react on this. Okay, how many data, information we should put into our event? There are 3 types of information. event data, it's everything related with particular scenario. For example, I've got build completed. So I can have information about what kind of test I run there. System, unit, integration, whatever. What kind of branch triggered this build. This is the information about this specific scenario. Reference data, those are the information that never change. But never change, it's important to be aware that never change within this specific context. We can change them in different, during different processing. A reference data for this example can be IP of the host. It won't change during this particular run. It won't. Another thing is state data. So whenever we've got these state view events, state change view events, we are putting all information about changing a state in here. For example, build is, we've got these builds, and builds are fixed. Builds are broken. This is the change of the state. No. It depends. It depends if you are interested in it. Usually, it would be good to put those information there. Why? Because it's extremely good to have all information about the event in the event itself. So yes, put those information there. It's wise approach. However, consumer doesn't have to use it. All information in the event itself, doesn't matter what kind of the type of the events, doesn't have to be used in the consumer. If I want to send a notification, the author of this specific branch, the information about the email of the author of this specific branch is enough for me. Other things are irrelevant. If I update my dashboard to show that master is right now green and it was red, the only information that I need is the state. I don't care about specific host. I don't care about the author of the commit. Okay. The important thing is when we should create the event. And there are many tips, but this is the most common mistake that at least we made. So that's why I'm sharing with you that. We've got two consumers. And here, before this, there is a question. There is yet another operation. This operation is waiting for it, for the consumption of the event, and analyze the event. So completed build can be either green or red. If it's green, then trigger this one. If it's red, trigger this one. If we've got something like that, such even data-driven flow, that means that we are missing something, and probably we miss an event. Of course, as you can see, there are build succeed, build failed. Of course, this won't disappear, but you should extract it as a yet another consumer, which will produce appropriate events and not trigger directly the consumer. Thanks to this, you've got more business information in your application. Hiding those information behind the code, behind those some magic ifs, conditions. Okay, so from the implementation perspective, yet another important concept is event processing network. And we've got 4 parts of it. Oh, okay, something to fix. We've got producers, channel, consumers. So producers is the part of our application that creates an event, that publish the event over the channel, and consumers, can be multiple consumers, are consuming the event from the channel. Of course, we may have many consumers here, but there is one important thing. It's event processor. This part, intermediaries, is responsible for processing of the events, and complex event. So sometimes my build is completed, okay, and here, this part here, build completed, build succeed failed, can be recognized in here. We are getting more information from the host that was running this particular. We got information whether it's failed or not, and depends on this information, we are creating our complex event that is giving our more detailed information about this particular event, and we are publishing it further. Here, the difference between event processor and consumer is extremely tricky, and the border is really tiny. Here, we shouldn't make any decision. We are just enriching. We can do calculation over the data. We can extract more information from them, but this is only about enriching, analysis, and so on. We are not making decision. Here, we are making decision, what will we do with this event? Should we do anything with this event? Okay, so events are here, published to the channel. That's
publishing another event is not actually doing something? Because in your example, we have this build finished event, and then we build completed.
okay.
And I suppose this PROIDEA will create build succeed.
So, this is not the good example for this event processor. The better example would be that's correct what you said. That would be something like here. So if I would like to refer to this one, build completed host IP, for example, and event processor should publish build completed as well, but with more detailed information. And probably succeed or fail should be a state of the event. State hold in the event. So good catch. Okay. So no. Depends on you. Depends on your own implementation. Okay, so I have to be fast. I've got 10 more minutes. Okay. Consumers. So they are consuming the event. We've got a few important information about consumer. So first, can consume various events. So as you can see, our notification can be sent whenever build is failed, whenever performance is degraded. But the same thing will happen. We will send information. We will notify people. Different event is triggering the action, but the thing that happens is exactly the same. Our reaction over the event is exactly the same. So consumer can consume, can be triggered by different various events. Many consumers can consume the same events, as you can see in here. If our performance build is degraded, if we recognize such possibility, we firstly want to create notification, send a notification to, I don't know, whole team, whole project. And we want to, for example, create a ticket in our ticketing service. Someone needs to take it and work on it, analyze it. We cannot leave it only with notification. So no event data-driven flow. I will cover that in a second. And not all event data have to be used. So you are taking from the event only information that are needed to your processing in the consumer. So as I said, here probably we will take, I don't know, stack trace. We will find we will gather, we will use all the information gathered to decide why the bit performance is degraded. Here we are using this information because we are creating ticket service. Here probably we will just inform that something happened. We'll take out the email of the people who are interested in such situation, and we will send the information that this happened. Okay, few challenges. What if consumers are doing the same thing? So we've got the situation like that, build failed, and if one build failed, we want to analyze whether our pipe is broken or still failing. So this is build analysis. And also, we want to send a notification about build performance degraded. We want to create a ticket, but we want to send a notification as well. If you see such a duplication, it's pretty easy to solve that. Just extract yet another consumer. It gives you great separation of concern. One thing is doing a job. If you will create yet another event that will trigger the notification, it's extremely easy to add. You know what are the prerequisites for sending notification. You need address, email address. So you are putting this information into your event, and then you can use it. If this build analysis is not used in the notification, yes, it is okay. However, if you would like to put here some additional information, that probably our line would go like that. First build failed, you are doing some analysis, then next event will trigger this one. However, here I am assuming that we are sending information that, okay, author of the commit, your build failed. Something is wrong with your tests. Okay. Okay, yet another thing, and this is this event-driven flow, data-driven flow. We are consuming the event, and in the consumer, we are making decision. So if the build is okay, if build succeed, we are triggering next build. We run our unit test. We want to run integration test. But if not, we are notifying the author. As you can see here, we've got totally different reaction over the thing. Totally different thing happened. There are this response with these questions. So succeed yes, succeed no, gives you additional information, additional business information, what really happened. So if you got a predicate that not make a decision over the event itself, but decide in which flow you should go, then probably you should create yet another consumer. Extract it, and this predicate is in here. So we will do this recognition, and it won't disappear. We need this information, but thanks to this, once again, we've got separation of concern. We are recognizing recognizing it here, triggering next build here, and we are notifying in this place. There is no problem with that. No problem with adding yet another events. No problem with changing. If we would like to, I know, remove it, we can just remove the consumer. That's all. How to find if it's too much? Try to express in one sentence without or and the user as well. If you can do that, then probably this is at least assumption. You may assume that your consumer is responsible for one thing. But if you have to add yet another part of the sentence and or, here we've got clear sentence. We will trigger next build or send notification. Here we will recognize the state of the build. We will trigger the build. We will send a notification. It's pretty straightforward. Okay, yet another challenge. Sometimes we've got a predicate. This is something that I show when I present an event. Predicate is before the consumer. So the solution is the same. We need yet another consumer. Producer are the place in our code that creates an event. Can produce different events, and how they are defined, which event will be produced. They are making decision over the event consumed. So here we've got our recognition of the build completed. We can check, is it failed or not? We can gather information, and then if it succeeds, create this one. If it's failed, create this one. However, even if they can create many of different events, they can produce only one event at a time. Only one thing happened. And what to do if you want, you have a need to produce more, I will show you in a second. And as I said, when I cover the complex events, there have to be some calculation, operations, decision making. If you are only enriching without any, usually there is some if in it. Without this if, you are probably creating yet another complex event. If if you are always producing one event, then you are probably talking about event processor, something that is create complex event. Okay, the one thing, how many time? Okay. Many of producers are also consumers. We are reacting over the event. Events are triggering our action, and we are doing something about that. We are making decision over it. As I said before, consumer can be triggered by different event. However, calculation in here have to be the same. So in that case, we've got builds analysis. We are taking all of the builds, and based on the event that is here, we are checking whether the state of all the builds changed. If yes, if no, then whatever the event in here will be, we are publishing builds not changed. If our builds were green and we received build succeed, they are still green, so builds not changed. If they were red and our build failed, builds not changed. However, if we notice the change of state, we are publishing a different event. So if it was green and we received build failed, builds broken. If it was red but it succeed, builds fixed. It can be like that. Operation in here are the same, regardless the event. We are just publishing different events, depends on the event consumed. Okay, so producer or consumer covered. Challenges, we've got few challenges with that. What if we are producing the same event by two producers? Probably we are doing too much in here, because to produce build failed, we need to recognize that build failed. So probably, most probably, there is maybe not the same code, but the code that is doing the same thing. It can be implemented in different way, but it will do the same. It is able to recognize that build fails. So how to tackle with that? Something like that. Here, our build state analyzes, build analyzes. So build completed, build not finished. For example, it can trigger build recognition, and we can recognize build failed, that build failed. Of course, the diagram doesn't always have to look like that. However, if you see something like that, that means that those two guys are doing the same thing. Not always in the same way, but the same thing, at least in some particular cases. And this particular case should be extracted. Okay. And this is the thing that I talked about a second ago, about producing more events. So we've got our builds analyzes, and we want to send a notification that build failed, and we want to update our builds dashboard. So if the build were green, we are recognizing that the change of all the builds is changed, so build is broken. And we are always publishing those events because we did this and this. Solution for that is pretty simple. we should have two consumers. Consumers and producers as well, because they are producing the event also. Okay. I showed you the example with this build fail. So if there are builds and where green, builds broken, where red and we receive succeed, build fixed. And what with these builds not changed? What we should do with that? It doesn't trigger anything. And for this, that's why there is no other tip. You have to decide. You have to decide what you want to do with this situation. Maybe for now, it's not interesting for you to publish this event. Maybe you right now the assumption is this doesn't trigger anything. Whatever decision you will make, there are consequences of that. If you will publish this event, pros, you will have the information. Yeah, something happened. This is business information. If our domain is continuous integration tool, this is business. This is domain knowledge. But the cons, you have to store that. You have to create that. You have to maintain this. On the other perspective, if you won't create it, then great. You don't care about this situation. You are not created the code that avoids you ain't gonna need it rule. Great. However, you are losing the knowledge. This knowledge doesn't have to be clearly expressed in our implementation of producer. However, this depends on you. Ending. Okay. This skip. Wide event-driven architecture. So summary. Separation of concern. It's extremely easy to maintain. You can, if your producers consumer are small, you have got the same situation like with microservices. You can remove them and replace them. It's extremely easy to extend and modify our flow. You always can add yet another customer for particular event. You always can remove particular consumer if you are not interested in this particular action anymore. You can remove producer if you are not interested in this event anymore. It's extremely easy to change those connection between the channel, producer, channel, consumer. Easy to test, and I encourage you to write component test for each producer and consumer. And thanks to this, it is easier to refactor. And even if you won't do that, write those component tests, it's easier to refactor, redesign, throw, and write from scratch tiny piece of the component, which is responsible for only one thing, rather than big monolith. What's next? Those are two books about event processing. I really encourage you to read them. If you want to see how event processing can be used in microservices, this is the book I suggest to read. And this is a third book if you want to see how event-driven architecture helps with SOAS. Okay, thank you very much. So no time for questions. But you can catch me just in a minute.